Everybody, in this lesson video, I am going to talk about spheres, and to get us started, I'm going to draw a picture of a sphere. Now, a sphere is a three-dimensional figure that is a collection of all the points three-dimensionally around a center. So I like to draw kind of like a circle, and then I kind of put an ellipse-like shape in there. Let's see, I'll have to size it a little bit. And then sometimes I also kind of do a line like this, maybe. Okay, we'll just keep it like that. That's fine. So we have a center here, maybe right here or so, and then that extends in any direction, right? That is our radius. Radius. So the volume of a sphere, you're going to write the formula for that. Volume of sphere. V for volume is equal to 4/3 pi times your radius cubed, because it is volume. We have three dimensions, and that is our formula. The volume of a sphere is 4/3 times pi times your radius cubed. And if you are interested in finding the surface area of a sphere, we actually do have a formula for that as well. And actually, I should write surface area of sphere. A lot of times for surface area, we use capital S to represent the surface area. And the surface area is 4 times pi r squared. Now, these formulas and many of our volume formulas are thanks to what is known as Cavaliere's principle. Actually, I'm going to write it. No, that's fine. Cavaliere's principle. And we're going to write out what this is, because it's going to apply a lot to what we do in later lessons as well. And we've already kind of used this idea already. So Cavaliere's principle says if two solids have equal heights and the cross sections have the same area, at every level in the height, then they have the same volume. In this formula, I kind of wrote in more simpler terms, but if two solids have equal heights and the cross sections drawn at every level parallel to the base, all of those cross sections are equal for both solids, then they have the same volume. So this is what allows us to find the volume of those slanted shapes, or we have stacked figures or other sorts of complex shapes. All right, now I do want to do an example with a sphere. So let's see, I put that down here. So this is our example problem that we are going to do. The circumference of a tennis ball is 21.5 centimeters. What is the volume rounded to the nearest hundredth of a cubic centimeter? So let's see, let's draw our tennis ball. I'll make it green. And tennis ball, ooh, that turned out not how I wanted it. The tennis ball is a type of sphere, so we know this is like a three-dimensional circular sort of shape. And we actually only know the circumference. So the circumference, or the distance around our circle, is 21.5 centimeters. And our goal is to find the volume. And again, volume, if I look at this formula up here, is 4/3 pi times our radius cubed. So we need our radius to find the volume. But luckily, since we have the circumference, we can use the circumference formula to help us find the radius. So the circumference is always 2 pi times your radius, or your diameter times pi. And we have the circumference. So 21.5 is equal to 2 pi times the radius. So to figure out what the radius is, I'm going to simply divide both sides by 2 pi. Since this is all multiplication, I can divide by 2 pi, divide by 2 pi. And I'm going to write our radius either as 21.5 divided by 2 pi, or we could write it as a decimal, and this is approximately 3.4218 ... centimeters. Now, our volume formula, I'm going to write it again. Volume of a sphere is 4/3 pi r cubed. So if I am working with a calculator such as Desmos, I could type in the volume is equal to 4/3 pi times our radius, which is 21.5 divided by 2 pi, right? The circumference divided by 2 pi cubed. Or I could type in our volume is equal to 4/3 pi times 3.4218 ... The more you round it, though, the more you are approximating it. I always like to say my rounding to the last step, but this radius has to be cubed. So I do have my graphing calculator right here. So I am going to type in 4/3, pi, and then our radius is going to be cubed. And our radius, I'm going to enter it first as 21.5 divided by 2 pi, again for pi. And that will get us an answer. Or you'll notice if I take this same structure and instead of the fraction, I put that decimal we got, 3.4218. You'll notice the more and more decimal places I add on, the closer and closer it gets to the true value when I am not approximating. So that's why I like to leave it in the truest form possible. But I would say our volume is approximately, if I'm rounding to the nearest hundredth, I don't want anything past the 2 that I see in both of these. And it looks like if we keep it as pi, that would cause it to round up. So maybe I will round up and I will write that our volume is 167.83 cubic centimeters. The volume is approximately 167.83 cubic centimeters. Please let me know what questions you have, and I look forward to seeing you soon.